These are our next-door neighbors, the triplets of Alpha Centauri. The red star, Proxima, is closest of all, at 4.3 light-years from Earth. The twin system known as W Ursa Majoris. Two stars so close, they constantly exchange material. Binaries and multiple stars are surprisingly common. But this is an exception. 3 sets of twins, 6 stars in all, orbiting around one another, 45 light-years away, the waltzing stars of Castor. Most of our neighbors are binaries, like Epsilon Bootis. Finally, on our neighborhood tour, the friendly stars of Ursa Major. Fly through them in space, and they form no pattern. But come back to Earth, and there they are, the Big Dipper, our most familiar stars. Beyond them, our galaxy contains 200 billion other stars, revealed to us now by astrophotography. Dawn seeps into the temple of Abu Simbel. In Egypt, 3,500 years ago, sunrise is a moment of reverence. When the first rays enter the Great Hall, the sun god Ra is reborn. To peoples of old, the sun governed both ritual and routine. The point of sunrise moved each day. The sun was a calendar. The need to measure time spawned astronomy, a science born of shadows and signs. Moonlight sheds an eerie glow on the ocean. The first observers had no notion of the moon's pull on tides, but the moon, like the sun and the stars, was a guiding light. From more than 30,000 years ago, timekeeping by the moon, a calendar carved on reindeer bone. Day by day, it records the lunar phases. But more important to our ancestors were seasonal alignments, moments when the moon or the sun marked a turning point. This burial site in Ireland is a Stone Age marker of the winter solstice. It was built so that on this shortest day of the year, the sun lights up the chamber of the tomb inside. Clouds permitting, it's never failed for 5,000 years. On December 21st, sunlight shines directly through a slit at this entrance. It happens only on this day. Lots of old buildings have celestial orientations. Many cathedrals are built east to west, but it's for heavenly reasons of another kind, Christian tradition. Further back in time, the pyramid builders of Egypt set their sights on the alignments of the stars. Weathering belies its former glory. Once a lavish mausoleum of limestone with a cap of gold, this is the Great Pyramid of the pharaoh Khufu. Inside, shafts supposedly align with special stars, looking out toward Khufu's route to immortality. An old Chinese map of the cosmos, but it was more. It was a reflection of the Chinese Empire. As the northern sky circles the pole star, so Beijing was built in rings around the imperial palace. This mix of myth and astronomy is epitomized at Abu Simbel. The temple was built by Ramesses the Great. No one's sure why, but it was so constructed that twice a year the sun lights up the gods within. It happens for a few days in February and October. Whatever the significance, we can only marvel at the precision. Whether for farming, fancy, or faith, the ancients knew their skies. Thousands of years ago, in the Celtic mists of northwest Europe, there were no temples to celestial gods. Instead, standing stones. Heroic rocks hauled upright by heroic men, rough-hewn markers to plot the progress through the seasons of the moon and the sun. Karnak, France, a megalithic wonderland, east to west, mile after mile of standing stones. Their precise purpose is lost. It had perhaps to do with the rising and setting of the moon and the sun. They're related to the great circles of Stonehenge in England, the most famous megalithic observatory. The key alignment is here, from the center of the circles, above the heel stone beyond, to the midsummer sunrise. The summer solstice, from the heart of an astronomical computer, 5,000 years old. It's so complex, a few archaeologists have suggested Stonehenge could predict eclipses of the sun. Unlikely, but eclipses of the moon are another story. Some of the oldest stones have intriguing alignments. These two mark the setting point of the midsummer sun. They also mark the setting point of the midwinter full moon. The moon passes through a cone of shadow cast by our planet. It's the time of a lunar eclipse. As the Earth blots out light from the sun, our shadow turns the moon blood red. The color is caused by our atmosphere. It bends the sunlight, and dust in the atmosphere deepens the redness of the shadow. In this partial eclipse, our shadow shows the curve of the Earth. Eclipses are simple, but why does the moon keep changing shape? Why does it go through phases? As it grows from a crescent to a full moon, the shadow isn't Earth's, but the moon's.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
As the moon wanes, the proportion of light to shadow that we see depends on the moon's angle to the sun. The ancients didn't understand it, but we can see how it works from out in space. From above the poles, we see the moon and Earth catching sunlight from the right. As it orbits Earth, the moon waxes and wanes to an observer on Earth. The cycle takes about 28 days. Here it is again, with the central frame showing the moon phase we see on Earth. The reason we always see the same face of the moon and never the other side is because the moon rotates just once in an orbit. If we could stop its orbit, we'd see it rotate. Observers of old may not have understood that it orbits the Earth, but they paid more attention than we do to the cycles of the moon. Eclipses of the sun are another matter. Some ancients understood that the moon was passing in front of the sun, but not that the Earth was a sphere. Here, the shadow of an eclipse moves across the planet. Within the black dot, the eclipse is total. On Earth, the sky is transformed. Little by little, the moon edges across the sun. A total eclipse. And with an exposure change on the camera, a halo appears. It's the corona, the outer atmosphere of the sun. Totality, as astronomers call it, can last over 7 minutes, a time. It's not just the moon that gets between us and the sun. A couple of planets do, Mercury and Venus. The Maya Indians of Central America knew all about Venus. Some of their temples were aligned to that planet. They used the complex motions of Venus to fine-tune their calendar. They could do it because Venus moves through the heavens in an 8-year cycle. The point where Venus sets today will repeat precisely in 8 years' time. The Mayans also used the stars of the Pleiades, the Seven Sisters. The Pleiades foretold the destruction of civilization once every 400 years. Tragically for the Mayans, the prediction was right. 400 years ago, their own civilization was wiped out by a race of men just an ocean away. The ancient Egyptians had different ideas. Sunset was the time to pay homage to a celestial wonder woman. She was Nut, a star-spangled goddess who swallowed the sun. By dawn, she'd eat the stars, too. But all was not lost. Nut would give birth to a new morning sun, and by sundown, to a new set of stars. Not all their notions were so fanciful. Egyptians were keen-eyed astronomers, and they noticed that the stars rise and set at a slightly earlier time each night. They saw the stars as patterns, as figures in the sky, and they realized that if the sun could be seen against those figures, it would move right across the heavens over the course of a year. This progress is what we call the ecliptic. The Babylonians gave it order. They split the ecliptic into 12 divisions, the signs of the zodiac. They imagined the sun tracking across the background stars. What they'd unknowingly observed was the Earth's orbit of the sun, our yearly cycle.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
The Babylonians believed their gods lived in wild places. To tempt them closer, they built but they were also observatories. We owe much to ancient Babylon. By naked eye, the Babylonians could record the movements of wandering stars, the planets. They knew 5 planets, with the sun and the moon, the 7 dominant objects of the sky. The Babylonians bequeathed them to us as the days of the week, their names recorded on the tablets of the cuneiform texts. The day of Mars. In French, it's still known as Mardi, although in English it's become Tuesday. The day of Mercury. In French, Mercredi, Wednesday. Jupiter Day. In French, Jeudi, Thursday. Venus Day. In French, Vendredi. For us, she's Friday. Saturn Day, simply Saturday. The day of the sun, Sunday. And the day of the moon, Monday. The Greeks tried to apply science to the universe. With Earth at the center, they set the heavenly bodies in concentric spheres of crystal. The Egyptians kept faith with myth and a star that preceded the yearly flood of the Nile. One season, their calendars were badly out of kilter. They'd lost track of the days and the time when their crops would be irrigated. They needn't have worried. The dog star Sirius rose to the occasion, and so did the Nile. In northern lands, the cycle of the seasons was marked by standing stones and by observing the horizon. The point where the sun rises shifts every day. But twice a year, it stands still. These times were recognized as midsummer and midwinter. When it moves again, the season begins to change. The world over, the movement of the sun was a calendar. In this Native American cave, when an arrow of sunlight strikes this spot on the wall, it's midwinter. Chichen Itza in Mexico, a Mayan city steeped in astronomy and religion. A citadel and observatory. A place of sacrifice. Here, offerings were made to the gods to ensure the rains returned. A special monument, the Castillo, and, at the equinoxes, the shadow of a god in the shape of a rattlesnake, a serpent of sunlight on a stairway from heaven. They didn't know it, but ancient observers were recording how Earth's orbit of the sun causes the seasons. That orbit is called a year. Each day, due to the tilt of Earth's axis, the angle at which sunlight strikes us changes slightly. Over a season, it changes a lot. In the 6 months from winter to summer, the change is greatest of all. From this position, it's summer in the northern hemisphere. The north has short nights and long days. At the equator, it hardly changes. The south has long nights and short days. From this opposing position, it's winter in the northern hemisphere. Short days and long nights in the north, the long days and short nights of summer in the south. Our ancestors had a clearer view of the cosmos than we do. From city and suburb, the stars are fogged by lights and pollution. Nowadays, vistas like this are glimpsed only in the remotest places. In days of old, everyone saw the sky and knew the sky. They wouldn't miss the lights of the aurora, or a new star, a nova, the sign of birth. Or a comet, a heavenly courier. Some astronomers suggest it was a comet that led the wise men to Bethlehem. Would they even see a comet today? Shooting stars were once a nightly show. To the Egyptians, there were messages from the gods. When a meteorite fell out of the sky, they set it on a plinth and called it the Stone of Heaven. The ancients watched the heavens the way we watch soap operas. The sky was a panoramic screen full of characters and beasts, a way to make sense of the stars. They helped shape the legends of mythology we know to this day.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
Our star maps have changed, but myth persists. The names of antiquity are the constellations of modern astronomy. But how did they reach us? For they had origins in different places and different cultures. Somehow, somewhere, the names of the constellations were codified. There's a theory it was the work of a lost civilization, a people dispersed more than 3,000 years ago after a volcanic disaster. They lived in the Aegean, on an island in the eastern Mediterranean known today as Thera, or Santorini. They were traders and navigators. Archaeologists have unearthed a wealth of artifacts and a seaport dating from 1450 BC. And there's evidence, some astronomers say, that star maps were made here, charts that name the constellations as we know them today. Perhaps those ancient observers on Santorini fed the legend of Atlantis, learned astronomers in flight from catastrophe. How high the moon, how far the stars. Around the world, astronomers pursue an age-old quest. They're down-to-earth people Scientists who understand the insignificance of our planet in the grand scheme of things. Since the time of the ancient Egyptians, the skies have scarcely changed. And the questions are the same. Will we ever reach those stars? How vast are the heavens? Questions that take us to the edge of time. In the quest to put a yardstick across the universe, the moon is our first measure. The moon is our only natural satellite. It's 250,000 miles away, and its light takes only a second to reach us. The Earth is one of 9 planets that orbit the Sun. The Sun is 93 million miles away, and its light takes over 8 minutes to reach us. From the outer planets, the Sun is just a brilliant star. Neptune is 3 billion miles from its warmth. Sunlight takes 4.5 hours to arrive here. Beyond the planets are the stars, but to the naked eye, they look the same, two-dimensional. Now, thanks to astronomy, we know much of their nature and their distance. Among these stars, if you don't count the Sun, is our nearest star, Alpha Centauri. It's the big one to the left. Alpha Centauri is 25 trillion miles from Earth. Alpha Centauri is more than one star. Indeed, it's more than 2. It's a triplet. Their light takes almost 4 1/3 years to reach us. Or, as astronomers would put it, Alpha Centauri is 4.3 light years from Earth. Out here, at such a distance, the Sun is a dot, a modest star visible to the naked eye. Onward and outward, and some 200 light years from home, the stars of W Ursa Majoris, twins that exchange material. Farther, and through the stars of Orion. From Earth, they're a two-dimensional pattern. Out here, we realize they lie at different distances. They have depth. We've reached 1,500 light years, and the heart of the constellation, the Orion Nebula. It's a great cloud of dust and hydrogen, a cocoon of gestation, a place where stars are born. If we kept traveling onward at the speed of light, it would take another 30,000 years to reach the center of our galaxy. Instead, we leave it. We journey to a vantage point outside, where we look back at our galaxy, a spiral of 200 billion stars, the Milky Way. But it's just one in a local group of galaxies. That group, in turn, is part of a bigger group, a supercluster. Superclusters form webs, networks that cross the universe, the voids between seemingly empty of galaxies. But there's more to the cosmos than meets the eye. Over 90% of its mass is invisible. It's called dark matter, a sea of exotic particles that possibly fills the universe.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
The Milky Way is big. A beam traveling at the speed of light at 186,000 miles a second takes 100,000 years to cross our galaxy. At the same speed, a journey through our solar system is a matter of hours. How do astronomers know all this? How did they learn to measure the universe? The story begins over 2,000 years ago in Egypt. It involves basic geometry, calculations familiar to temple builders.